So today's the 23rd. And we're going to learn today just the basics of logarithms. And I think that when I teach things, I'm very sensitive to how I felt about them as a student. And I remember being very intimidated by logarithms. It's one of those things that I don't even remember when it came into full, clear understanding for me. It may have been in college. I don't really remember, but at some point I went, "Oh, is that all this is?" And then it was like, "Okay, not bad." So I'm a little bit nervous about things like this, just because I know how initially scary it can be. But um, I'm gonna just kind of put some examples up here on the board and see if maybe you guys can crack the code. What you're going to be doing today is the part that's after the equal sign is what you're going to be calculating today. What you're going to be doing is called evaluating a logarithm. And it's no different than 2 plus 2. If I said evaluate 2 plus 2, you'd put 4. If I said evaluate 10 to the third power, you'd say, oh, that's 1,000. Like evaluating expressions is just something you're really familiar with, except now you're going to be evaluating logarithmic expressions. And again, once you get past the hurdle, it's not bad at all. Can anyone make sense of the first sentence? I mean, it's so weird to even like, why would log base 4 of 16 equal 2? Like, what does that even mean? It's ridiculous. What if I go ahead?
Or like if you
Like, start, let's just focus on this top one and tell me more about what you were about to say, because I think you're on the right track.
there's fours that
That's it. Yeah, you're going to see me and hear me refer to this as I don't know when this started, and maybe I should stop. But see, people seem to take to it, so you'll hear me refer to this as a water cycle. And the where this comes from is the fact that, and I always say this because to me it reminds me of the science in science class. You guys remember the water cycle? How the water starts down here and then it cycles up into the air and then it falls back down to the earth and then it cycles. Have you ever seen that like in science class? That's what logarithms have always felt like to me. And so I draw it that way. And then that's just what we start saying. It's like a day from now or 2 days when I say, what are you going to do? You'll say, like, hit it with the water cycle or something like that. And what it looks like is this. You start with this number. This is called the base of the logarithm. And you raise it to the power of 2. And the answer is 16. All three characters in that performance have names. 4, I do want you to know this. I'm not heavy on vocab, but it makes our time together easier if you can use the correct words. So 4, the little number down below, that's called it's like a subscript. So it's not log 4, like it's log base 4. You got to make it smaller and down low. That 4 is called the base of the logarithm. 2 is called the logarithm. And 16 is called the argument. So we say a log with a base of 4 and an argument of 16 is equal to 2. The words we use the most are base and argument. The logarithm is more just kind of a way of saying that's like the, I hate to say this, but like the air quotes answer, if you will. So that's how the relationship exists. It's the base to the power of the logarithm has to equal the argument. And having said that, you can see why the other ones also make perfect sense. If you water cycle the rest of them as well, you can see that sure enough, 3 to the power of 4 is equal to 81. And you can see it again, that 2 to the power of 3 is equal to 8. Okay, so what we're going to do for the next 15, 20 minutes is we're going to evaluate logarithms ourselves. They're obviously not all that simple, or this would be a really short thing. I'd already be probably, quite frankly, almost done. But I'm going to put some logs up here now, and I want you to help me evaluate them. So what's going to be missing once we start the problems here is these numbers over here won't be there. So our job is to figure out what they are. What is the log, basically? So let's get to it. And I do have a sheet that I will hand out to you. In fact, let me write all of these down and then I'll walk around and I'll give you a sheet. I have a cheat sheet for you that has lots of useful math facts on it. And you'll see, like, you probably don't need it for either of these first two, but log base 7 of 117,649 is a little bit obscene. Um, and same with log base 4 of 1,024. So go ahead and work on those. I'm going to pause this and I'm going to walk around and hand you guys out a piece of paper that will help you a lot.
Is there no logs on those because
That the logarithm is equal to what? Good. So the answer is 6. Remember, when you answer a logarithm, all you're giving is an exponent. You're giving the power required to make a relationship true, right? You probably didn't need a calculator for or a sheet or anything for this second one. What's log base 9 of 9? 1, because you have to raise 9 to the 1th. This is where you see a resource like this coming in really handy. Log base 7 of a huge number. So you go to your 7 column, and what power of 7 is equal to the argument? So the answer to the logarithm is, again, 6. What's log base 4 of 1024? 5. Good. So keep your hands on that sheet. That's yours. You don't ever want to like turn that back into me or something. That's just for you. I found this online, I think, years ago, and it's just something that sits on my hard drive, and I just kind of hold on to it until we do logs because you definitely want it. You're going to find yourself not needing the sheet for stuff like this. Like right now, you need it. That's okay. But eventually, you're going to start to memorize these sorts of things. What power of 9 is equal to 729? And you'll just know that. You'll walk out of this unit just knowing that 9 to the third is 729. You'll know 8 cubed and 6 cubed and 5 to the fourth and all these things that before would have seemed utterly useless. But they'll just stick sort of because they will. Okay. So let's talk about these bottom two, the two where I did not put a base. Has anyone come up with a theory as to what you think the invisible base would be? It's 10. This is called, these two right here have a name. These are called common logs. And that I also need you to know. A common log is a base 10 log. And the reason we call it common is because humans, we work in a base 10 number system. Our number system evolved on planet Earth because we have 10 fingers. So if you've ever wondered why we do everything in tens, so like why is moving the decimal place times 10 or divided by 10? It's humans evolved the language of math because of the numbers of fingers that we could count on. It's not a coincidence. That's why numbers are called digits, the same as your fingers. So we work in a base 10 number system. It's the same in Germany as it is in America. I mean, most of us have 10 fingers, right? And so that's where this is. So a common logarithm, it's just, we call it that because it's the most commonly seen thing in human mathematics. So I'm going to write it in here, but I won't usually. Log of 100 is really log base 10 of 100. And what does that equal? 2. Okay. Bless you. What's log of 100,000? 5. So that's sort of the introductory phase of this. There's one other kind of log that you're going to see before we get to the second level of these, and it's this one. In fact, I'm going to erase everything else on the screen because, yes, you like it. Uh, ln. So the natural log is a log with a base of a number e. And this one will cause some panic. There's a number that naturally occurs in mathematics called E. It's the same as pi. You know, pi is not something that humans came up with. You should know that by now. Pi isn't some number that some guy in a cave with a long beard invented. Pi is a naturally occurring number that happens when you take any circular thing and you measure the distance around the circle and you divide it by the distance across the circle, regardless of the size of the circle, that's called pi. And it's an infinitely long decimal that never repeats and never ends. The same for the number e. And you don't have to worry about what e is for today. It's around 2.71828, but you don't have to know that to get through this. But a natural log is another way of saying a log, log, with a base of e. So if I said to you, what's the natural log of e? Think about that. What's log base e of e? What do you have to raise e to make e? 1. What do you think the natural log of e squared is? Think about the redundant nature of this question. In other words, let me write this out for you. A log with a base of e with an argument of e squared. The question is so silly that no one can ever answer it right on the first try. What would you have to raise e to make it e squared? Nope. The answer is 2. What do you think the natural log of e to the 10th is? 10. What do you think the natural log of e to the 54th is? 54. Good. So basically, logs are going to come at you in 3 flavors, and then we're going to move on to the harder ones here in a second. There's these logs here where the base is just visible and you just do the math. And then there's common logs with the invisible base of 10. And then there's natural logs, and I do need you to write that down. So when you see ln, I know that it seems like it comes in the wrong order. It should be like log natural, but they're called natural logs. And that's because in nature, naturally, the number e comes into existence. And there's all sorts of YouTube videos that I might wind up playing for you at some point to give you a little heads up as to how does e exist. I think it's interesting, but I'm me. So got it?
There's natural logs, common logs, and logs.
And just logs. Yeah. So natural log is an ln, log with a base of e. Common log is a log with an invisible base of 10. And then there's just logs. Those are the ones with log base 2, log base 3, log base 5, stuff like that. So let me ask you guys some math questions. And these are some obscure facts from your past that you may or may not remember. I'm going to give you the first one for free. 5 to the power of negative 2 equals 1 over 25. What the what? How do you think that comes into existence? You squared the 5, but notice, where did I square it? In the denominator. So you could quickly take from that and say, I mean, you learned this at one point in our past. I don't know how long ago it was, but if something has a negative exponent, what you do is you effectively pick it up and move it and then evaluate the exponent. So like 10 to the negative third is really the same as 1 over 10 to the positive third. So the answer would be 1 over 1,000, correct? What do you think 4 to the negative second is? 1 over 4 to the second, which is 1 over 16. 4 squared is 16. This is where you would be looking at your sheet right now to get a little step ahead of me and say, okay, I get where he's going with this. I know the answer to this fourth one is going to be 1 over a relatively large number, 8 to the third, which is 512. And again, that's one of those useless facts that you will just memorize because you will, out of necessity, all right? 8 to the third, 6 to the fourth, they're all just things that are going to get stuck in your head. Okay. Okay, so you wonder, like, why did I bring that up? Well, I brought it up because of this. What's log base 3 of 1/9? The question I'm really asking you right now is this. 3 to what power equals 1 over 9? What's the first thing I know about the exponent that I'm looking for? It has to be a negative to cause that fractional flip-flop, right? So I know the answer is negative. And then the question simply becomes, what power of 3 do I need to make a 9? 3 to the third is 27. So the answer is -2. About log base 4 of 1/64th. Again, the question is 4 raised to what power equals 1 over 64? Negative, what'd you say? Nope, 3. 48th is massive. It's 65,536. So, okay. How about this one? Again, you're not going to fall for this, right? You now know that that's not I didn't forget to write the base. What's the base? When the base is missing, it's a 10. So the question is 10 to what power? Say again? Negative 4. It's negative because I caused the downstairs flip-flop. It's 4 because I need 4 tens to make 10,000. Let's go again. Log base 2 of 1/32. -5. Good. So what I saved, oh, well, let's get this one out of the way first. Natural log, remember, it's just a log. Don't panic. It's just got a base of e, the number e. So it's -1. Good. I need the negative to cause it to move downstairs. And Kennedy's like, I only need one of them because it's not e to any power. So it's just negative, but it's -1. So like, what would the natural log of 1 over e to the 7th be? -7. So you should be now poised for these last 7 minutes that we have together to tackle some of these now. These are the ones I was a little bit leery about going down this road with you today, but I'm going to give it a shot. And these will be the hardest ones without a doubt. Okay. So do you know, and what I should say is, do you remember that this is true? This would have been something we would have talked about in Algebra 1 a long, long time ago, that rational exponents can be turned into roots. So like 10 to the power of 1/2 is equal to the square root of 2. Let me give you another one. How about 15 to the power of 1/4 is equal to the 4th root of 15. Let me give you another one. 23 to the power of 4/5 is equal to the 5th root of 23 to the 4th power. Can you make sense of what you just wrote down or what you're still writing down? Can you make sense of the relationship between the thing on the left and the thing on the right? Good. You see this 2 that I just circled in red? That's a square root. Let me show you again. See the 4? That's a 4th root. See the 5? That's a 5th root. The top number 4 became the exponent. Okay. So, having said that, I present to you now a significantly more difficult question. What is log base 5 of the cube root of 5? What is the answer? So what is the answer? What do I write right there? 1/3. Think about the water cycle again. And Irene was on it. I was just trying to get her to just say the power because the log is just the power. Look at the water cycle. Do you all agree that 5 to the power of 1/3 is equal to the cube root of 5? Let's try again. Before I step up to the final difficulty level, let's try this. What is log base 8 of the fourth root of 8? Let me clarify. Close. 8. Think about the water cycle again. 8 to what power equals the fourth root of 8? This is where I kind of knew we'd hit a stall. The answer is 1/4. And the reason is because we know, I'll write this in green for you, that 8 to the power of 1/4 is equivalent to the fourth root of 8, right? Okay, let's go again. Log base 6 of the fifth root of 6 squared. You've cracked the code, Irene. Congratulations. 2/5. It's simply a matter of this over this. Let's go again. Log base 11 of the seventh root of 11 to the fourth. The answer is 4/7. We've got more people jumping on the bandwagon. Good job. Let's see if in the next minute or 30 seconds I can get 10 more or 8 more of you to jump on. What is log base 5 of the square root of 5 to the fifth?
It's just five. It's just five. One.
What number's right there? What number's right there? 2. Remember with roots, when you don't see an index, that there's a 2, right? So what is this one going to be? 5/2. It's really just a matter of constructing a fraction out of the red number and the yellow number. So here's what we're going to do. We're going to stop here. And then we'll resume this conversation tomorrow. Right before I give you a chance to work on your tests, I will wrap up. There's one more level of difficulty that I was unable to get to, but that's okay. So we're gonna I'll say this on the recording. Here's what I want you to do. In the next 23 hours and 10 minutes before I see you again, I'd like you to get on Delta Math and try some problems. There are going to be some that you don't know yet quite how to do, but I want you to get in there. Try to get a handful of them right. And so that when we revisit tomorrow, then you'll be nice and fresh.